Alright, so in this video, I'm going to be solving a challenging system of equations. So the first equation in my system of equations is x squared minus y squared is equal to 24. And the second equation is x times y is equal to 35. So, in the system of equations, I can label this the first equation and this the second equation. And I want to find the value of x plus y. So to do that, I'm going to use my first equation first. I'm going to start with that. And what I'm going to do is I'm going to rewrite this as x plus y times x minus y is equal to 24. Because if I have something in the form a squared minus b squared, it's equal to a plus b times a minus b. Now from here, what I'm going to do is square both sides. So this turns into x plus y times x minus y squared is equal to 24 squared. And this is equal to x plus y squared times x minus y squared is equal to 24 squared. Now, I'm going to expand x plus y squared. So x plus y squared is the same thing as x squared plus 2xy plus y squared. And x minus y squared turns into x squared minus 2xy plus y squared. And this is all equal to 24 squared. And now, from here, I'm going to use my second equation, which is x times y is equal to 35. And what I'm going to do is plug this value into here, because notice how we have x times y right here and right here. So now I get x squared plus 2 times 35 plus y squared times x squared minus 2 times 35 plus y squared is equal to 24 squared. And this turned into x squared plus 70 plus y squared times x squared minus 70 plus y squared. And this is equal to 24 squared. So now from here, remember how if I have something in the form a plus b times a minus b, this is equal to a squared minus b squared. Well, in this case, I can say that a is x squared plus y squared and b is 70. So this turns into x squared plus y squared squared is equal to 576 plus 4,900. And now if I take the square root on both sides, the square root of x squared plus y squared squared is just x squared plus y squared. And this is equal to the square root of 5,476. And the square root of 5,476 is equal to positive or negative 74. So now remember how x plus y squared is equal to x squared plus y squared plus 2xy. Well, x squared plus y squared is equal to positive or negative 74. So now I get x plus y squared is equal to positive or negative 74 plus 2 times xy. And also remember how x times y is 35. So now I get x plus y squared is equal to positive or negative 74 plus 2 times 35. Now, 2 times 35 is 70. So I get x plus y squared is a positive negative 74 plus 70. So now, this gives me two equations. I get x plus y squared is equal to 74 plus 70, and x plus y squared is equal to negative 74 plus 70. So to start, I'm going to solve x plus y squared is equal to 74 plus 70. So this turns into x plus y squared is equal to 144. And now if I take the square root on both sides, the square root of x plus y squared is just x plus y, and the square root of 144 is equal to positive or negative 12. So these are two values of x plus y. And now from here, for x plus y squared is equal to negative 74 plus 70, to solve this turns into x plus y squared is equal to negative 74 plus 70 is negative 4. And now I'm going to take the square root of both sides. So the square root of x plus y squared is x plus y. And the square root of negative 4, well, to actually solve this, many people probably think that you can't take the square root of a negative number, but you actually can. So what I'm going to do is I'm going to rewrite this as the square root of negative 4 times negative 1. And now this can be written as the square root of negative 4, or sorry, this should be the square root of 4 times negative 1. And now this turns into the square root of 4 times the square root of negative 1. And if you guys already know, the square root of negative 1 is equal to I. So this turns to, so the square root of 4 is positive negative 2, and the square root of negative 1 is I. So these are another two solutions. So my four solutions for x plus y are 12, negative 12, positive 2i, and negative 2i. So these are my four solutions.